Well, I hope you enjoyed that little introduction courtesy of Sora and Sonu. So look, I have had so much fun building this cute little project, and I want to share it with you so that you can have fun too. To get started, please look below and follow the link to the GitHub and clone the repo and read the README and follow the instructions so that you can bring up Jupyter Lab, and that is where we will go right now. So here we are in Jupyter Lab getting ready for action. You've done the basics, you've followed the README, and you should be confronted by this screen. Now, as you probably guessed, what we're doing here is building an arena for battling LLMs against each other using the great classic game of Connect 4. And it turns out that that's quite hard for LLMs because whilst it's pretty easy to write computer programs that are very, very good at Connect 4, in fact, it is a solved game, so you can play a perfect game. It turns out that that is much harder for something that is reasoning by pure language to figure out what's going on in the board. And it does turn out that reasoning models do a better job of it. So the way I've approached this is I've built a quick prototype that shows you the bits and pieces, and we're going to work on the prototype. And when the prototype is working, we'll switch to the big game. All right, so without further ado, let's go into the prototype. So here we are in the prototype lab, prototype.ipython notebook on the left. And let me take you through what we do here. I start by doing some imports, and I load in the environment file, the .env file that hopefully you've set up. I then define a few constants to get our board game up and running. Red, yellow, empty being our three possible pieces, a little dictionary to map those pieces to a nice icon, and some text, and then the column names A through to G. Okay. So I usually like to set up a little class to get things started, and this is a very simple class indeed. It all fits on one screen like this. So it's called board, and it has cells, self.cells, which, as you can see there, is empty. It might be nicer if we called that empty. Empty from the 7 across and 6 down. The current player is red, and the winner is empty. And then this is a way that you can write a default method that will print the board. And the way we're going to do it is we're just going to loop from the rows and the columns, and then just use this show dictionary that we defined up here to print each cell. And you can probably imagine the reason there's a 5 minus y there is that the row that we think of as the bottom row in fact needs to get printed last. So you have to reverse the order as you print. Hopefully that makes some sense. And then we'll show at the end who's winning and who's playing. I've got a little function here as well that prints this in JSON format, because JSON is something that computers find easy to understand. And it just creates a sort of JSON structure with column names and rows and so on. So anyway, let's see what this actually looks like. Let's create a new instance of board. And that's what it looks like immediately. You can see there's a board with empty squares and it's red to play. And now let's see that in JSON. Here it is. It looks like a JSON structure. I just made up the JSON structure that feels like it's going to be giving the right kind of information, the column names, and then each row in turn. And now hopefully you see what I mean about the rows obviously being printed in reverse order. Okay, so far so good. Next, we're going to add in some more useful methods into our class, our board class, something that will tell us the height of any given column, something that will then tell us what are the legal moves that are allowed, and then a function which will actually make a move and update the cells as a result. So let's see, what does that mean? Let's add those methods in. So now we're going to create a board. We're going to call move for the third column, second column, and then print the board. And it should hopefully switch the players. You can see here how it switches the players after each move. So far, this has got nothing to do with AI. This is simply setting up a sort of arena construct. The AI part is coming imminently. All right, I run that, and there you go. You can see, true to my word, we've made 3 moves. It's now yellow's turn to play, and you can see the board being printed. Super easy. If I ask for legal moves, we get to see that every column right now is a legal move. Okay, now there's a little bit of stuff in this next cell. This is how to figure out whether or not the board is complete, whether there is 4 in a row. You can check through this, but it's just a little bit of checking trickery figure out if there's a winning line at this location X and Y. If you go in DX and DY direction, check 4 squares, and you can see by looking through this that it's going to return red or yellow if there is 4 in a row going in that direction. And then this winning cell takes X and Y, and it looks this way, this way, this way, and this way to see if there is 4 in a row. And now you might be wondering, why don't I also look the other 4 ways, going backwards? Although you may already figure this out, it's because if we're going to test every single square in turn to see if that is the beginning of a 4 in a row, then we only need to look in one direction, because another square will be a match going the other way. So otherwise we would look in every direction twice. And this all gets us to this simple function, the simple method wins, which is going to look through every single cell and see whether that is a cell that is basically on the bottom left of any 4 in a row. And then move is a function that actually makes a move and sees if there's a winner, and if so, sets that winner. So this is effectively replacing the move, the simple move that we wrote a minute ago. Okay, so with that, let's see how this looks. Let's create a new board. Let's move 2, 3, 2, 3, 2, 3, 2, and see what happens. Bam! So you can see that, of course, red is now a winner with 4 in a row. It appears to be working. We're almost there. This is almost the end of it. We've got the big class to come, player, that is coming right now. And now we arrive at the player class, which is where AI finally makes its entrance. So the player class has 3 variables: color, which is red or yellow; model, which is the name of the model we'll be using underlying it; and LLM, which will be the Python client library that we'll be using, in this case, OpenAI. Now, students of my LLM engineering course will be very familiar with system prompts and user prompts and the way that I like to write functions to create each in this quite structured way. And in the case of the system prompt, we need to set the tone of what's going on, set the context. You are an expert player of the board game Connect 4. Players take turns to drop counters into one of 7 columns labeled A through G. The winner, first player to get 4 coins in a row. You are playing with these coins, and your opponent is playing with these coins. And we lay out the structure. We also say that you should respond in JSON, and only in JSON, according to this spec. And here we have evaluation, threats, opportunities, strategy, and a move column. Now, there's a few reasons to do this. One reason is because it's cool to be able to see our Connect 4 game underway and see what the LLM is actually thinking. But the more important reason is that this forces the model to be working in a kind of reasoning mode. Even non-reasoning models, we're forcing it to express its thinking before it comes up with its answer. And you should experiment. If you take this out and just have it pick a column and that's all it does, then its play can be much more random and there's a much less thought process going behind it, quite literally. And when you make it spell it out, it biases the model towards coming up with a good rationale, and it will bias it towards projecting a move column consistent with what it's come up with before. So it's this extraordinary thing that we've known about now for a long time, since the beginning of chain of thought prompting, that just by asking an LLM to think through its steps and express them, you get better outcomes. So that is the system prompt. Let's talk about the user prompt. And here is the user prompt. It's very similar. There's never a harm in being repetitious with this prompting, but it's good to express it slightly differently. So I'm saying it's your turn to make a move. The current board position is, and again, we're putting the JSON version of the board in here, which is the version that will probably make the most sense to a model. You'll see when we get to the final code version that I do actually put 2 different versions of the board, a JSON version and a different version, just to really try and heavily bias the model. And again, we have it respond in JSON according to this spec. If you're wondering why there's 2 curly braces here, not 1 curly brace, it's because this is actually being written within an F string, and within an F string, a single curly brace means code, and 2 curly braces means an actual literal curly brace. If you didn't expect that. And in the move column, I'm actually giving it, again, the legal moves in there. And you may guess this, but the reason I do this is I found that even with good models, it was often the case that they would reply with an illegal column, however much I tried to tell them to always make legal moves. So forcing it many times really helps. And in fact, in the final code version, I even print out the illegal columns and say this will cause you to forfeit the game if you pick one of these, to heavily bias it. Okay, and so then there's a process move function, which is we'll have it print it so we can see, and then we will load in the reply, find the move column, and then make the move. If it makes an illegal move, if there's some sort of an exception, then it forfeits the game. And we're almost done. This is the move function that just sets a system prompt, a user prompt, and then we make the famous call to OpenAI, which, as everyone that's done my LLM engineering course knows so well, the API call is you call the client library.chat.completions.create. This is the OpenAI structure, which is a bit different to Claude's structure, but consistent. You can use this also with Gemini, with Ollama running locally, with Groq, with DeepSeek. So it's very, very common. You specify the model to use, and then you pass in the messages using this particular format, a list of dicts that was kind of invented by OpenAI and is now used ubiquitously across the LLM field, a dictionary with the system prompt going in one dictionary and the user prompt going in another. And then you take the reply from that, you take choices0.message.content, that's the text that comes back, and I call the function above with that. And that, if I execute that, is all there is to our prototype of our game. Do you think it's going to work? Let's find out. And just before we do this, I made an intentional error in the previous cell. Maybe you spotted it, particularly people on my course probably did. When we call the client library, client.chat.completions.create, we should specify that we want a JSON object in the response format that will force it to respond with JSON. This is also the technique you use to do things like structured outputs that we cover on the course. But this is a way that we ensure that we get JSON back. So let's run that. And now it is time for us to play our game. So we create a new board. We create a red player, GPT-4o Mini. And let's create a yellow player and have the yellow player be GPT-4o, the bigger cousin. And then we have a simple loop. While there's no winner, red makes a move, yellow makes a move. As simple as that. Could it be this simple? Could we have built a whole arena and game in the space of 10 minutes? And could these two LLMs duke it out? Let's find out. So we start the game and off it goes, thinking, and we get back a move. GPT-4o Mini has moved to the center column at D. It recognizes that there are no pieces. And then GPT-4o responds also in the center. 4o Mini puts on top. And so does 4o, and they're filling up. And now it is red's turn to play. And red is thinking. And it moves to E. And people probably know, yes, that 4 has to make that move. Otherwise, it would have been a lost game. So this is looking interesting. It's heating up. It's heating up. Take a moment to appreciate how extraordinary it is that with so little code, we have two language models arguing and thinking their way through a complex game of Connect 4. And it's a longer game than they normally are. I should point out that one of the ways these games sometimes end is by one making an illegal move, particularly when the board gets more complicated, which, as far as I'm concerned, that's a true result. That means that we've exceeded the LLM's capacity to think. Well, it's a long game, that's for sure. They don't normally last this long. Do we see any potential wins on the horizon? This could be the first time ever that there's a draw. That would be a new... oh, no, it's yellow can win if yellow goes... but yellow missed the opportunity. Yellow has another opportunity and misses it again. So GPT-4 and has now lost that opportunity, wasn't able to appreciate. And there's plenty of opportunity to GPT-4o to win right now. and yellow just won with a 4 right here. So it was a long game, and interestingly, both models had opportunities to win sooner and missed them. But yellow did win, so GPT-4 triumphed over the smaller model, GPT-4o Mini. Well, I hope that was interesting and revealing. It certainly shows how easy it is to build something like this so quickly. But what I want to do now is take this to the next level. I want to go to Python code rather than a Jupyter Lab. I want to bring you into PyCharm and show you a more organized way of doing this in a more bulletproof way, and a way that will allow us to test out many different models and build our own leaderboard. As everyone who's seen my other stuff knows, I love Jupyter Lab. I think it's such a great environment for prototyping, exploring. It's good for education. It's good for R&D. But there's a time when it's the moment to move into a professional IDE like VS Code or PyCharm. PyCharm is my weapon of choice, but I know there's lots of VS Code people out there, and either will do great for this. And you can stick in Jupyter Lab as well if you want. I've gone ahead and built some Python modules which build this code in a slightly more professional way. So for example, if we look at board, this is the same board code that we built in that Jupyter Lab, but it's been structured a bit nicer. I've even put in some comments, and I put in some type hints from place to place. I've also, in addition to the JSON representation that we made of the board, I've made an alternative representation, which is a sort of more of a text style representation that might be easier for some LLMs. And in the prompts, I now give both versions. Otherwise, this is basically the same as before. Now, I've also got a class called board view, which is able to make an SVG version of the board, which drops in the pieces. And this code looks pretty complex and unwieldy, and it's pretty clever stuff. And I have to tell you that I am a lousy front-end developer, and there's no way that I could have done this. This might have taken me at the very least several hours, maybe even a day. But Claude just wrote this for me. And it made a little mistake, and we had to find it and fix it, which took about 20 minutes. But basically, this stuff was written by an LLM. Most of the rest of this was written by me, but the user interface part, this part here, this is not my work. And it's amazing how easy it was to explain what needed to be done and get it done so well. Now this here, the module called C4, is a module which contains the Gradio code to bring up the user interface. And Gradio is something that I know and love. I really enjoy building Gradio user interfaces. It looks a bit sprawling, some of this, which is one of the things about writing lots of Gradio UIs, but you get used to it. And by all means, take a look through this at some point, but it's not super important. The next two, though, are super important. Game is the overall module which organizes everything together with a board and players. You can reset the game, you can make a move, you can see if the game is active, you can print the thoughts of either player, and there's also some functionality here to retrieve from a database prior games and their ratings. And LLM is the other super important class. This is a wrapper around all the potential LLMs that we could want to call. We've got the API code for Gemini, for O3 Mini, for O1, for GPT, and also for running Ollama models locally and everything else. So it's a bunch of wrapper codes of API calls, and then a superclass LLM that just supports the method send. In many ways, this is similar to if you use a lightweight abstraction layer like Light LLM. It gives you this kind of thing. But it turns out it's super easy just to write it yourself, because all the different calls to APIs are very, very easy. And most of them just share OpenAI's common structure. So writing this was something that I enjoyed doing myself, and it allowed me to use each of the different API calls separately and test them out. So I think it's a good exercise, a good practice. But for sure, if you're used to using something like Light LLM, you can also just drop that in. And for the real diehard LangChain people there, of course, you can use LangChain's classes as well. But that does add, of course, it brings in the LangChain ecosystem in quite a way. But it's absolutely something that could be done. Player is just the same player that you know well. And record is just an extra module I added that allows it to connect to a Mongo database to bring in records of prior games so that we could build a leaderboard. And that's it. That's how I've structured the code. And that's how I've made it just a bit more robust and flexible. And really, the reason I wanted to take you through this is to show you how you can sort of move from prototyping in the lab to moving into a PyCharm or a VS Code environment. And also this trick of having a very, very lightweight abstraction layer around your calls to the model, which you can use so that you have sort of one interface to the outside world that can be switchable for you. And so with that, I now want to show you the finished product. Here we are back in the browser window with JupyterLab running where I left it. And I've just typed in a prompt Python app.py, which is all you need to do to bring it up. And it's on this tab here. And let me show you what it looks like. Here it is. Here's the beautiful Gradio app looking super simple and with the SVG that Claude wrote for me. And now I can simply choose models from this drop down here and choose models from this drop down here and have them play against each other, which is such fun. I'm going to start by choosing two very fast models. I'm using Groq, Groq with a Q, not Groq with a K. Groq with a K is, of course, the LLM from X that is a very powerful LLM. Groq with a Q isn't an LLM. It is a platform for running high-performance inference on open-source models using dedicated hardware, using proprietary hardware. And so we can do that to run like Llama 3.370 billion, the massive version of Llama 3.3, against the Mistral, one of its largest flagship products, LLMs, and this should run nice and fast. And we can press next move to play a move at a time, and look at the way the coin just drops down. Again, all credit to Claude for that. And you can see the moves being made, and you can see on the left and on the right the inner thoughts being displayed of the LLM. I'm going to make this a bit bigger for you. There we go. We're now going to press run game that will set the game back to fresh again and run an entire game while we watch. And it will be nice and fast because Groq is super powerful. It's so fast it sometimes makes the move before it's even finished the animation. And this shows that Llama 3.3 triumphed very, very quickly and easily. Mistral was not able to see that a 4 in a row was building there. Let's try a more interesting match right now. The match that everybody wants to see, of course, would be to start over. And let's try putting DeepSeek against, what should we do? O1 Mini. Let's have DeepSeek against O1 Mini. Now, start that going. It's not going to be as fast because these are two heavyweight models that will take a bit of time. This is a championship match of the Titans. Now, you may wonder why I'm using DeepSeek V3 and not R1. I've had problems, first of all, stability problems, that R1 is overused and will sometimes just fail to reply. And secondly, it can get itself in a loop where it keeps thinking and going backwards and forwards and can't make a decision. So I've actually had some difficulty getting R1 to be coherent in replying to this particular game, whereas the other reasoning models seem to be okay. But we'll see how it gets on now. You can see that the game has started interestingly with DeepSeek trying to build a 4 right there, but O1 Mini has spotted it coming. Now, while this continues to run, one thing I can do is flip over to the other tab and show you the leaderboard. The leaderboard over here is showing you, first of all, on the right, all the different games that have been played, that have been stored. And so if you come and play it yourself, it will add to the list here. And on the left here is the ELO rating of different LLMs based on the matches they played against each other. And this game will contribute to ELO. And this is still fairly early on, and I only built this yesterday. So there haven't been that many games. You can see I played it a fair bit, but other people have too. And this leaderboard is likely to shift. But as of right now, O1 Mini is in the first place, and DeepSeek is a couple down. But we'll see how this game is developing. It's looking like yellow now has an opportunity to win. O1 Mini might win if it makes the right move right as we watch. Let's see what happens. This could be the moment. Hopefully that's easy enough for O1 Mini. It is easy enough. O1 Mini makes the winning move, and O1 Mini has triumphed over DeepSeek Chat v3, which failed to spot that right there. Okay, with that, I have one more thing to show you, and then it's a wrap. And the final thing to show you is that I have this running on my website for anyone to try it out. And I'm being generous and offering up quite a few nice models. Not O1, I can't afford that for everybody, but GPT-4o, the big guy, and a bunch of others, and a distilled version of DeepSeek. Distilled means that this is actually the 70 billion version of Llama 3.3, and it has been trained off synthetic data generated by DeepSeek. And that means that it has really strong performance of DeepSeek R1, and it performs pretty well, and it's nice and fast because we're going through Groq. So you can go to my website at ebadon.com and click on Connect 4, and then play games as you wish, test out different models. And the thing to keep in mind is watch how it thinks things through, use it as an opportunity to understand a little bit more about what's going on during model inference, and also to compare the strengths of different models and just to have fun. And then come to the leaderboard, and if you've run some games using the run game button, using this one button here, then you will contribute to the leaderboard, and we'll be able to see how this shakes up in time. And I hope to add more. And of course, we hear that GPT-5 might be on the horizon, and I would love to add GPT-5 into the mix as well. So stay tuned for all of that. The serious point is that although this has been really good fun, I've loved making this project, it was so simple to do it, so quick to build this, just in a few days. And take a look at the code, see how things like the abstraction layer around the LLMs is so light, you can just do it yourself. The different API calls to different LLMs, how to run Ollama locally so that you can run this using local open source models, and some of the other techniques around prompting that I've used in there as well. And if this is interesting to you and you'd like to know more and you haven't seen my LLM engineering course on Udemy, then please go check it out. I'll put a link there. And I also speak at some O'Reilly events too. If this hasn't put you off, you want to hear more of this, then please do that. And please also connect with me on LinkedIn. And if you've got any questions about this at all, I'll put my email address there as well. Feel free to badger me anytime, pester me. And if you can't get this to run locally, I would love to help you because I'm really thrilled by the idea that people actually use this themselves. So at the end of that, thank you for hanging on in there till the end. Thank you for being part of this, and I hope you enjoy it.